Hello, welcome to Chapter 9, homework questions 38 through 43. Question 38, write and solve a system of equations for the situation described below. Define your variables and write your solutions as a sentence. Daria has all nickels and quarters. The number of nickels is 3 more than twice the number of quarters. If she has $1.90 in all, how many nickels does Daria have? So we need to write our let statements. What variables are we talking about? What things are we looking for? So we want to know how many nickels she has. So let's let n equal the number of nickels. We're also talking about quarters, so let's let q equal the number of quarters. And so now we can set up a system. The number of nickels, so the number of nickels is 3 more than twice the number of quarters. So 3 more than twice the number of quarters. So twice the number of quarters plus 3. And then we also know she has $1.90 in total. So a nickel is 5 cents, a quarter is 25 cents, and a total, instead of using $1.90, I'm going to use 190 cents. That way I don't have to use decimals for the value of the nickel and the quarter. So there's my two equations, and now I can solve choosing any method I want. I'm going to use substitution because n is already solved for, so that'll be 5 times 2q plus 3 plus 25q is equal to 190. Go ahead and use the distributive property. Combine your like terms. I'm also going to subtract 15 at the same time, so this would be 35q is equal to $175 because I'm using cents. And then divide by 35. So q is equal to 5. That would be the number of quarters. So then I can take that, since it does ask the question how many nickels she has. So n is equal to 2 times 5 plus 3. So 10 plus 3 is equal to 13 nickels. So make sure once again that you write your solution as a sentence as it states up here. And the question was, how many nickels does Daria have? So Daria has 13 nickels. Question 39. Solve the following quadratic equation using any method. So we get to pick what method we want to use. On question A, we have 10,000 x squared minus 64 is equal to 0. And so you might recognize the last term definitely is a perfect square of 64. The first term is that a perfect square. And it is. 100 times 100 would be 10,000. So we can use our factoring, even though these numbers are a little bit larger, but because they are both perfect squares, and it's a difference of perfect squares, we can factor this relatively easily, and then we can set our factors equal to 0 using the zero product property. And therefore when we solve, we will add 8 and then divide by 100. So x is equal to 0.08, and the same thing will happen on the other side. We're going to subtract 8 though, and then divide by 100, so we'll get x is equal to negative 0.08. So we could say or, put an or in between those, or we can write it as a solution set, negative 0.08, comma 0.08. But you have to use the curly brackets if you're going to do that. On to B. We have 9x squared minus 8 is equal to negative 34x. So it looks like we're going to have to set this equal to 0 by adding 34x to both sides. That's the middle term, so we want 9x squared plus 34x minus 8 is equal to 0. We could try to factor this if we don't want to. Maybe the numbers are too large. Not sure if you're going to be able to figure it out. You could always use the quadratic formula. I'm going to go ahead and look to see at least if it is factorable. So we have a 9x squared and a negative 8. So we're looking for numbers that multiply to give us negative 72x squared and add to give us 34x. And it looks like this will work. We'll get 36x and negative 2x. That would multiply to give us negative 72, but add to give us 34. So we'll put those numbers into our generic rectangle and then figure out the side lengths. And so it looks like this would be an x, this will be a 9x, which will make this a positive 4 and this a minus 2 on that side. So it does factor to 9x minus 2 and x plus 4 is equal to 0. And as I said, if you chose to use the quadratic formula, that's perfectly fine as well. We will get the same answers either way. The left side, 9x minus 2 equals 0, would be x equals 2/9, and then subtract 4. So it looks like our answers are 2/9 or negative 4. So x is equal to negative 4 comma 2/9. And once again, either one of those solution sets in terms of how you write it is correct. Question C. 2x squared minus 4x plus 7 is equal to 0. These numbers are pretty small, so I would say let's go ahead and try to see if we can factor it. This would be 2x squared and positive 7. So we're looking for numbers that multiply to give us 14x squared and add to give us negative 4. There's not too many factors of 14. You have 1 and 14 and 2 and 7. 1 and 14 would not work. 2 and 7, to get the negative, we would either have to have one of them be negative and one of them be positive, but since it's a positive 14, they would both have to be negative. So it looks like that's not going to work. It's not factorable. It doesn't mean it doesn't have solution, it's just not factorable. So let's go ahead and use the quadratic formula on this one. A is 2, B is negative 4, and C is 7. So x is equal to the opposite of B plus or minus the square root of B squared. Since B is a negative, make sure you square the negative 4 to get positive 16 minus 4 times A times C all over 2 times 2. So as we simplify this, we get 4 plus or minus the square root. I'm just going to go ahead and plug that whole thing in and see what we get. And we get a negative 40 divided by 4. Now, hopefully right away you recognize that we are going to take the square root of a negative number, which means we're not going to get any real solutions. So we can stop here and just say that there are no real solutions to this quadratic equation, which means that the graph is somewhere above or below the x-axis. Since it does open up, it would be above the x-axis, and it doesn't cross the x-axis. And on to the last one, D. We have 3.2x plus 0.2x squared minus 5 is equal to 0. On this one, we need to get them in the correct order. So 0.2x squared plus 3.2x minus 5. Since we are dealing with decimals, probably the quadratic formula would be probably the best method here. We could get rid of the decimals by multiplying through by 10 if we wanted to. That could potentially help as well. I'm just going to go ahead and leave them as is and identify what A, B, and C are, and then plug them into the quadratic formula. So the opposite of B plus or minus the square root of B squared minus 4 times A times C divided by 2 times A. And so that'll be negative 3.2 plus or minus. I'm going to go ahead and plug that into the calculator. I get 14.24, and that's divided by 0.4. So 14.24, if you try to take the square root of that, that is not a perfect square, so we're just going to go ahead and separate them right now. We have x equals negative 3.2 minus the square root of 14.24 divided by 0.4. We'll figure out what that is on the calculator, and then the second one is x equals negative 3.2 plus the square root of 14.24 divided by 0.4. And 14.24 is approximately 3.77. But let's go ahead and plug this in and see what we get. So on this one we get x is approximately negative 17.4, And then on this one, we're going to get x is approximately 1.4. So those would be your two solutions. Once again, we can say x is approximately negative 17.4 or x is approximately 1.4, or we can use our curvy brackets to write our solution set. And so that's how you can solve a quadratic equation using any of the methods. Now, I didn't see one on here that was necessarily good for completing the square, but once again, any of those methods would be fine. Question 40. Find a rule that represents the number of tiles in figure X for the tile pattern below. So you can see figure 1, and you can count up the tiles, 6, 7, 8. So this one has 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then we can do the next one. Let's 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So it's a 4 by 5, so that's 20. And then add the extra 4, so that's 24. So 8 to 15, you're adding 7. 15 to 24, you're adding 9. So you don't necessarily see the pattern that we've seen before with linear. So we have to think about this a little bit different. Look at figure 1, and what you might notice is there's always this rectangular tile pattern in each of these. So I'll go through and kind of outline it each time. And what you also notice, maybe, hopefully, is that there's this one tile that's always here. It's always just one tile. But on the other side, there's one in the first one. There's these two in the second one. And then these 3 in the third. So it looks like it's just adding the figure number to the bottom right corner there. So how do we tie all this together? Well, this side length is 2 by 3. Then it's a 3 by 4, and then a 4 by 5. So if we're basing it off of the figure 1, then on this side, that means you're taking the figure number, I'm going to call it x, and adding 1 to it. And then on this side it's 3, so that's taking the figure number 1 and adding 2 to it. Does that work every time? Well, this is figure 2. If I add 1 to figure 2, that gives me 3. If I add 2 to figure 2, that gives me 4. Figure 3, if I add 1, I get 4. If I add 2, I get 5. So it does appear that it works x plus 1 times x plus 2, but then you have to add in the extra 1 that you always have and the extra x tiles you have here based on the figure number. So let's put all that together and see what we get. We're going to have x plus 1 times x plus 2. That'll give you that center section every single time. And then you have plus x, that's that section over here that you're adding the figure number for every time. And then don't forget about that extra 1 that's up there. And so if I want to simplify that, I'm going to say y is equal to, that represents the total tiles. We can distribute the x plus 1 times the x plus 2. So that'd be x squared plus 3x plus 2 plus x plus 1. So if we combine our like terms, x squared plus 4x plus 3. So if we wanted to simplify it all out, no matter which way you did it, if you simplified it, you would always get x squared plus 4x plus 3. Question 41. Solve the equations below for x and then check your solutions. So we have 3x squared plus 3x is equal to 6 plus 3x squared. So it initially looks like it could be a quadratic that we have to solve, but once we start setting it equal to 0, we notice that the x squared terms cancel out. So we're just left with 3x equals 6. Now we're just solving a linear equation, and x is equal to 2. And so then below it I showed you, since it does tell us to check our solutions, I want to show ahead and showed you the check below that it does work. On to example B. 5 over x is equal to 1/3. This one we can multiply both sides by 3x. That will get rid of the denominator on both sides, so I'm going to write this out so you can see it. 5 over x times 3x over 1 is equal to 1/3 times 3x over 1. And what that does is allow us to cancel out the x variables on this side. So 5 times 3 is 15. And allows us to cancel the 3's on that side, and that is equal to x. So x is equal to 15. And then I will show you the check on that as well. And there's check. Pretty short on that one. 5/15 reduces to 1/3. And on to C. 5 minus the quantity, 2x minus 3 is equal to negative 3x plus 6. We'll start first by distributing the negative sign or the subtraction sign inside the parentheses. So that would be 5 minus 2x plus 3. And then we can combine our like terms. So 5 plus 3 is 8. 8 minus 2x is equal to negative 3x plus 6. Then we need to work on getting the variable term on one side. And so that's 8 plus x is equal to 6. And then work on getting the constant to the other side. So if we subtract 8, x is equal to negative 2. And so there's the check on that one by plugging in negative 2. Using your order of operations to simplify. And both sides should be equal to 12. On to part D. Instead of rewriting that, I'm just going to go ahead and distribute so I can start simplifying right away. 6 times x is 6x. 6 times negative 3 would be minus 18. Plus 2x is equal to 4 times 2x is 8x. 4 times positive 1 is 4. And then minus 22. And now we can combine our like terms. So that's 8x minus 18 is equal to 8x minus 18. So once again, just like before, getting the variable term on the same side. But when we do that on this one, we notice that the variables cancel out. And we're left with negative 18 equals negative 18, which is a true statement. So all values of x will work. So we're going to say x is equal to all real numbers. And to check on that one a little bit harder because you can plug in any number and it should always work. Question 42. Line L passes through the points given, while at line M has the rule y equals 6 plus 3x. Which line is steeper? And we have to justify our answer. Well, when it's wanting to know how steep a line is, we want to look at its slope. So for line L, we're going to find the slope by using our slope formula, or you can use a table and look at the change of y over the change of x. Either way works. So I'm going to do the change of y, 42 minus 94, over the change of x, negative 44 minus negative 31. And so I will get, let's see, negative 52 over negative 13. That's minus a negative 31, so that's plus. And then if you take 52 divided by 13, you get 4. So that'd be the slope of line L. Let's go ahead and look at line M. Now line M is giving you the equation y equals 6 plus 3x, or 3x plus 6. So this one has a slope of 3. So is a slope of 4 or a slope of 3 steeper? Well, on 4, you're going to go up 4 over 1, whereas 3, you're only going to go up 3 and over 1. So the bigger the number is, the steeper the line is. So line L would be steeper. And so I just said line L is steeper because the slope is larger than line M's slope, because it does want to make sure that we justify our answer. Question 43. No payments for the first 6 months. You just bought a new tablet computer for $500, including tax. There are no required payments for 6 months, but the company does charge 30% annual interest, compounded monthly, on any unpaid balance. What is the monthly multiplier? And then if you do not make any payments for 6 months, how much will you now owe for your new tablet? So what is the monthly multiplier? Well, the company does charge 30% annual interest. So the word annual is yearly, but it's compounded per month. So over 1 year, that 30% is going to be compounded monthly. So if we want to figure out what the monthly multiplier is, then we'll have to take the 30% and divide it by 12 to see what it would be per month, and that would be 0.025. Now remember, we always start at 100%, and in this case, 100% in all cases is 1. So if we take 1 and we add the 0.025 instead of converting it back to a percent, we'll get a monthly multiplier of 1.025. That's how much it's going to increase per month. The 100% representing the amount that you currently owe. If you do not make any payments for 6 months, how much will you now owe for your new tablet? So it says no payments for the first 6 months, but they're charging you interest. So how much are you now going to owe after 6 months? So we'd have y is equal to the initial amount of $500 times your multiplier, 1.025, and for 6 months, we'll raise that to the 6th power. Plug that into your calculator and see what you get. And so I got a value of $579.85. So if you don't make any payments for 6 months, you're now going to owe $79, almost $80 more on that tablet, and that's if you pay it all at once. And so once again, to make sure we answer the question, you will owe, or the tablet will cost after 6 months, if you make no payments, will cost $579.85.